In this video, I will answer these questions using kinematics and forces. So the first thing to do when you're solving the problem, draw a picture of it, put the labels in every place that they need to be. So I've labeled times, I've labeled the initial speed, the mass, the distance, final time. Then I've got a list of knowns and then unknowns, things I need to find. So acceleration, force, final speed are the things that I'm looking for. So now, first thing I want to do, I want to get rid of the quarter mile because that's not an SI unit. So a quarter mile, I look for the conversion factor. So in my copy of the textbook, it says that 1 mile is 1,609 meters. So if I take 1,609, multiply it by 1/4, I'll get 402. So a distance of 402 meters. So now, we need to find acceleration. What do we have? Acceleration is a change in velocity over time. We don't have a change in velocity. So we can't use that. We do have, let's see, we have an initial and a final position, and an initial and final time. So if we can find an equation that's got acceleration, initial time, final time, it can have the initial velocity. That sounds like this one. So x is x naught plus v naught x times t plus 1/2 ax t squared. Initial velocity is 0, so this goes away. Initial position, we can call the initial position 0, and then final position will be 402 meters. So 402 meters is 1/2 acceleration in the x direction times 10.4 seconds squared. So that we can solve to get acceleration in the x direction. There's only an x direction. The car is not flying up off of the road. So this will give us the acceleration vector is something in the x direction. It will be meters divided by seconds squared. So that's good, the units work. So now I just have to do the math on this. 7.44 meters per second squared. So now we've got that. How much force is needed? Well, I have acceleration and I have mass. So I know that force is mass times acceleration. So this is the net force. 1,500 kilograms times 7.44 meters per second squared. Kilogram meters per second squared, that's newtons, so that's good. It's about 11,200 newtons. So now we've got the force. Final velocity. Final velocity, now that we have acceleration and time, and initial velocity, we find the final velocity. The final velocity is initial velocity plus acceleration times time. So ax, v naught x, final in the x. So v final, that's what we're looking for. V naught, that was 0, plus 7.44 meters per second squared times 10.4 seconds. .4 meters per second. Does that seem like a reasonable number? See, it's a fast car, right? It's been going for 10 seconds. That's a fairly long amount of time. So I'd expect that it could be going pretty fast. It's about 2 miles per hour for 1 meter per second. So that means this car would be going about 150 miles an hour after a quarter mile. So that's pretty fast.